Today, this is week 3, and this is where we are going to move from AI-assisted coding to a kind of delivery. So in week 1, we just did a tour around Github Copilot, what it does, what it's all about. In week 2, we talked about prompting. Just so we are aware, only 2 people have submitted their hands-on labs. So please do try to do those hands-on labs and try to submit them using the link I sent. I think I've pinned the link in our group chat. So in week 2, we mastered prompting and chat controls. So I will try my best not to repeat those foundations today. But today, week 3, we're going to focus deep into coordinating more with plan mode, agent mode. And by the end of this class, you should be able to do the same thing I'm going to do. There's an hands-on lab again at the end. If you have any questions about what I'm showing you, just raise your hand and I will try my best to answer as much as I can. And if I cannot answer it on the fly, I'm going to try to answer after the class. All right, so this is the structure for today's class. The first section will be more of an operating model, and the second section will be more of like a guided live implementation on how this works. So yes, we are going to be using one project throughout today. We're going to be building a task application. We're going to start from an empty folder, and step by step, I'm going to show us how to build a task API with Flask. We're going to run some tests. I'm going to talk about testing, why we need to do testing, and add a clean UI on top of the API. Now, let's look at this slide that shows us the difference between the old way in which we used to handle AI and now on how we handle AI. So on the left, you ask for small pieces of code, you just copy and paste them, you run the commands yourself, you fix the problem one by one. On the right is the new way of using agent, called the agent mode. You explain the results you want and any rules to follow. Then the agent does more of an handwork. It finds the right files, it makes the updates, it runs the checks, and it fixes the issue. So the most important message here is that we stop asking for tiny code pieces and we start asking the agent for full outcomes. So before you just ask the AI, like what are changes I can make? AI will give you the code, you try the code, you adjust it yourself. But in agent mode right now, the agent will be the one to like find the code itself, run the code itself, self-correct the code itself, investigate why it's failing itself, and do everything itself, right? So agent mode is just like a faster helper, but not a replacement of your judgment. You still decide what good looks like, and you approve the final results. So we've spoken about agent mode from week 1, week 2, week 3. We've done some tests, but not like a big test. So how does agent mode works? So in agent mode, there's a life cycle mental mode for agent mode. First, it understands the objective, right? You give it a clear goal. So there's a 7-step flow to the agent mode. You first give the agent a clear goal, then the agent find the right files and information. So finding the right files, for example, is if it's like an already built app, it finds like, okay, what is the app Sarah wants me to fix? Or if it's a fresh new folder, what file do I need to create for this use case to work? It also searches the internet for more information, right? Then step 3, it decides the order of the work. Then step 4 is that it makes the changes. Then the 5th step, it runs checks like, okay, is this working as it should work? So it does things like testing. But again, this also depends on the kind of prompting you have available. Then the 6th step is like it self-corrects. If something breaks, it fixes it itself. Then step 7 is for it to return the results. So when you are trying to prompt, you should also have this in mind as well. So if your request is vague, your results will be weak. But if your request is clear, your results will be more reliable. Now, agent mode is very powerful. So again, you need some clear rules before you start. So you have to give it a clear scope. Look at the difference between these two slides, right? See the one that you have to avoid, like fix everything. But if you give it like an explicit scope, like fix a particular issue in this particular folder is different from like fix everything, right? So you have to give the agents a clear scope, avoid vague things like fix everything, don't run unknown script without testing, and don't skip testing to save time, especially when it comes to production. and don't merge like your code without reviewing it. Also, don't keep secrets in your prompts, right? So secret or keys are the kind of things you need when you're building an application that the application needs to talk to. For example, if you want to use AI in your application and you want to connect to AI Foundry or any of these other AI tools, you need like a key to be able to connect to that AI model. So you don't want to put the endpoint in your code, right? You want to use an environment variable, right? So that is an example of what to avoid and things to do. So everything basically is based on optimization. You need to optimize like when you're giving it your prompts. We've already discussed this in responsible AI principles in week 1. So I'll try my best not to repeat that again today. So what we're doing today basically is we're going to apply everything we've learned in week 1 and week 2, and I'm going to try to show us the kind of prompts I'm going to use to build a simple application. But before I go straight to the demo, I just want to explain some of the key things I may be saying that may be, since most of us here are not from developer background, so some of these things may be like foreign to us. So you may be hearing of back end, back end, back end. So what is back end? So it's a part of the application that handles, like in this instance, the task data and the rules, right? Then front end is the page where the user sees and click. For example, if you ask Google something, what you are asking, that thing you're asking Google is called the front end. That place where you are typing those things are called the front end. And the back end is like you don't know what Google is doing at the background to get you that information. That is the back end. Then we also have what we call the API. So the API is the way the front end talks to the back end. So that's what it uses to talk to the back end and the front end. So that's what an API is, right? So in this project I'm going to build right now, it's going to be a task API. So what it means is that it's going to handle actions like create a task, list a task, and update a task status. And we're also going to create what we call a test. So for us to test if the API is working before we even start doing our front end. All right. Do we have any questions so far before I jump straight into demo mode? Okay, no question. All right, so basically what we're doing today is we are beginning to build stuff, and I'm beginning to show us how it's going to work in GitHub. And so you can start learning some processes, especially for people without software engineering background. So I'm going to open a folder and I'm going to create a new folder called week 3. Mind the right, yeah, week 3 folder. And I'm going to select this folder. So now we have everything plain. Nothing is going on. Then I'm going to give it a prompt. So let me just show you what my prompts look like so we can see. So I've already written down some prompts before this class. So I don't edit every time I want to do something. So I'm going to, for the first demo, I'm going to give you this prompt, the requirement. You can see the requirements, and I'm asking to build a tiny Flask API. I already gave it what I want. Return 400 error if there's no title, right? I'm going to also ask the agent to also create a test that verify that the API is working, right? So, and I'm also going to create these files as well. So after the agent is working, I should be able to see these files. So again, that's what it comes when it comes to prompting. I'm already telling the agent what I want and what it should execute and what the final output should include as well for my agent mode. So when you are trying to create an application using GitHub Copilot, you want to make sure that you have, like, again, the requirements for this agent to run on. You want to make sure that you have the kind of files you want to see. If it's a Python file, if you're using JavaScript. So these are the kind of things you should consider when you are using an agent mode in GitHub Copilot. So I'm going to paste the prompt here and let's see how it works. What we are doing right now is we are creating the back end brain to prove that before adding the front end. So there's not going to be any beautification yet. It's just us trying to build the back end. And that's how it works in real life. Trying to build the back end, how this application is going to work. But again, my prompts can also be created using Copilot, any of the Copilots, GitHub Copilot or your normal Microsoft 365 Copilot. If you have an idea, you can create a prompt. You can ask Copilot to able to generate a prompt, but you need to know what your app is consist of, right? So you need to do research on what your app should look like, what you want your app to look like, what you want your app to do, the step by step. Like, for example, if it's like Uber, or if it's like an app that you can order food, right? You need to know the things that your application will need in the back end, right? From the user perspective, from the restaurant perspective that will pick up the food order. So those are the kind of things you need to also know if you are trying to build an application. And for every time you run an agent mode, you will always see this thing like, do you want to allow all commands in this session, or do you want to configure auto approve? So I'm going to allow all commands in this session. So it's going to run. So we can see from an empty folder now, it has created different tests that I'm going to use to run my tests. It has created an application, my backend application. Right now, if we run this thing, it's not going to give us like a UI yet, because there is no UI yet for this application. It's just the backend. And now what it's trying to run now is trying to check if everything has been satisfied, if it's created a requirement as well. So this is the Flask version it's creating using the requirements folder. So it's going to check everything itself based on my prompts to check if everything that we ask it to create has been done. So it is creating the app. At the same time, it's also testing the app. At the same time, it's also going to tell us if the test runs. So it's going to keep on running the test until all the test runs green. So if the test runs green, it means that, okay, our application is ready to be used, and the tests that the test I put in the via the prompt is making everything work well. So that is what an agent mode can do. So basically, today's class is going to be more of us moving from agent mode to plan mode back to agent mode, and to build this particular simple application that we are building. So if we can see that 4 of our tests passed in 0.5 seconds, right? So it has checked the health, it has checked the validation, it has checked the update as well. So everything run very well. And it also add a README file, which I'll talk about in as we move via the as we move further, I'll talk about the README file as well. So, but in basically, README file is like, okay, it's also created a documentation for somebody to be able to understand what this Flask API we created is used for, right? So again, all these things are things that you can do yourself when you are trying to create your final application in week 6 or I think week 6 or week 7. So we're just trying to build into that. Then, so now we've watched how like a raw execution from an empty folder, right? So now we need to add control. So as our project grows, speed alone is not enough. If we keep changing the code without planning, mistake is going to increase. And that is where the plan modes come into place, right? So first we need to define what we want to change. Then we want to define what we must not break, and then list how we test it. So in simple English, what this means is that you need to think before typing. So now we've created that application, just the backend. We've done the test. It is working very okay, right? So now, what if we want to make changes to our application? What do we need to do? For example, you are working in a department and they ask you to create a particular application, but definitely your customer is going to keep asking you to add more features. Even your own personal projects, you may get very excited by creating something, right? And you want to add more features, right? Maybe an AI chatbot. Maybe your app is working normally, but you want to be able to add an AI chatbot that is going to be asking questions based on the internet or based on your documentation, right? So if you want to add more things to your application, how do you go about it? Even without GitHub Copilot, the first thing you want to do is to plan, right? You want to plan those changes, right? So that's the same thing with GitHub Copilot. I'm going to walk through all this block. If you want to make changes to your application, you need to be able to plan the changes you're going to make. So first thing is scope. So what exactly are we changing in this application right now? And what are we not changing, right? So if your scope is fuzzy, everything downstream becomes unstable. So after you've identified, like know what you want to change, the next is to identify the impacted files and dependencies. For example, if it is only the UI we want to change, so we don't need to change our API, our tests, or some other things like that, right? So you want to analyze which of this file is going to be impacted by this change, or that we're going to make these changes on, right? For example, if you want to add more priority to your task, for example, if you already have a task, if you want to add priority to that task, you may want to change your API validation or your test, etc. Then the next thing again is sequencing. So you want to choose the safest order of your work, right? How do you want to make these changes? Which one do you want to change first before the next change in your files? Do you want to change the UI before you change the backend, or do you want to change the backend before the UI, right? So these are the things you also need to know as a vibe coder or as a developer using GitHub Copilot. Then the next thing is validation. So how do I know that this thing I'm doing is validated? As I mentioned in our last call, for example, if I'm making a changes to my user inputs or my user password, maybe before the password was four letters, and now the EU or EU have created a new law that all passwords must be 6 letters, right? And you want to change your apps to obey the EU regulations, just as an example. How do I validate it? How do I know that, okay, all the code that we've made changes to in that particular file, how do I do those tests to prove that it's done, right? So that is what validation is when you're planning. Then the next thing is risk. So what can break and how do I roll back, right? So knowing your breakpoints and having a rollback strategy is something you want to plan as well when you are building an application. Then handoff. So handoff is like, okay, we're done planning. Let me send the approved plan to the agents. So instead of just telling the agents like, oh, EU said we should do this and do that, make these changes. You want to make sure that you have your plan, you have the file, so that the agent does not change all the files. You already know the files that needs to be changed. You've already done your validation before you are now handing off over to agents mode to make those changes. So if your team is the kind of team that often rewrites features, I'm sure some of us have worked with some customers or some clients in any kind of job we've done. It can even be customer support, right? Where the customer is always requesting for more things and more things and more things, right? So I just work as a support person. We've received a lot of cases. I've received a lot of cases of like customer asking for Microsoft to change one button, customer asking for Microsoft to use their own country as the first country that they want to see. Like you should check their IP address, and when they want to do a drop down of countries, sort of Afghanistan, which is the first country in the list, they want to see like Nigeria first or United States of America first. So those kind of changes that you want to make, you have to plan for every changes, especially if it's an application that is going to be used by a lot of people. Okay, so this is also best practices when you are building an application using GitHub. Now, also when planning, you also have to have like a good prompt, and there's also a bad prompt. So a weak prompt, for example, would be like add authentication. It may sound clear, right? But it's missing key details like, as I mentioned earlier on, what files do I want to change for this authentication? What should remain the same? How should I validate? How should I text sources, right? Am I using a regex? What should I do if it fails? Is there going to be a 400 error, or should I just put a red button that says, or a red text that says, change your password? This password is not, So things like that, you want to make sure that, you give your planning prompt as well a very good direction. So now look at the strong prompt example. You are giving it like a scope of change, like actionable plan, create an implementation plan to add to this particular authentication. You're also including the affected files, like, okay, we are using this file. And another example would be like, okay, add feature X to this particular application, but keep the existing routes working, right? So that's an example of kind of like stronger prompts that you want to use. So a weak prompt is just a wish. I wish the sky is blue. Why a strong prompt is that for the sky to be blue, let us turn this color, let us put this color in. That's not a good example, but you get what I mean. So that is an example of a strong prompt. Hope am I recording? Okay, been recorded. All right. So the next thing I want to show us is a demo of using a plan mode as well. So now in our plan mode, I want to add a priority feed to the task. So I want to show us again the kind of prompts I'm going to be using for this particular addition, but I will not make the changes yet until we move to the next stage. So again, I've added these prompts. here as well. Again, all this prompt was created to me by Copilot, by the way, and I just wrote them down so that we can see what it looks like. So you can see in my prompt, I'm saying you are in plan mode only. Do not edit these files yet, right? And I'm saying again, I'm a beginner developer, right? So priority, add a new task field name priority to ensure that my task API accepts it. Create a step-by-step implementation, and your plan must explicitly cover these review goals. Let me increase this thing so we can see it well. Is this file complete? Is the sequences safe? Are the text explicit? Is failure? And so these are the things I want the plan mode to be able to cover, and the requirements as well for this plan to cover. So that way, when the plan is like running, it already knows what I need. So I'm not just wishing that something happens. It's me trying to plan accordingly. So where is the Visual Studio? Okay, I think it's this one we are using, right? Week 3, yes. So I'm going to change to plan mode. Again, if you want to change to plan mode, you come here, you see the agents. So I'm going to change to plan mode, and I'm going to copy and paste my prompts that I have created using Copilot. I'm going to send that, and it's going to work on its own. So while that is working, I'm going to go back to our slide and talk about sub-agents. So we can see for the plans already reviewing our current code base, but the first agent mode did not review the current code base because there was nothing there. But this time around, it's reviewing our current code base, it's checking all the files that we have, then it's going to begin to plan those changes. But it's not going to make any changes to our code. So it's just going to plan it. So while it's working in the background, I'm just going to go back to our slides because of time and talk about sub-agents. So now we know what an agent does. It makes changes. It can help us build our application, right? But what happens when we have like so many things we need to do that we're going to be doing all over and all over again, right? That's when sub-agents and why they matter. So sub-agents is not about doing more things at once. They are used for separating concern boundaries, right? So in this example that I'm doing here, right, we are looking at different sub-agents. So the first sub-agent we're going to be doing is research sub-agents. So what his job is to check where changes are needed, which part of the app will be touched, right? Then the second sub-agent is testing sub-agents. So what this does in our code is that we can create another agent, not the general agent that we're using. So anytime we want to do anything that has to do with testing, we just use that testing sub-agent that we have already created. Anytime we want to do anything that has to do with debugging, we use that debugging sub-agent we have created. If we want to do some changes in our documentation, we use the documentation sub-agent that we have created. So instead of using that single agent, single session, we can always use this sub-agent that we've already created, right? And I'm going to show us how to create a sub-agent in the example that we are creating. And we can now use plan mode with those sub-agents. So now the major use cases of using sub-agents in a practical scenario would be, first, you can use to check like API impacts, check your data, if you are connecting to a data, check your model changes, right? So that is what you can use a kind of agents to do, like want to do a large refactor. So what does this mean? It means like you have an application, right, that is already working, but you want to make a very, 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 very big change. So you can create different sub-agents by different domains, like an API sub-agent, a data sub-agent, a test sub-agent, to be able to make those changes. Then another reason why you can use a sub-agent will be legacy code onboarding. Now, some of our applications, or some of the applications, if you're going to be working for an organization, they are inheriting like code that people that wrote in 1999 or 2000 or 2001, right? And they are scared of making some changes. So another reason you can use a sub-agent in this instance would be when you want to use an old code base. Normally people feel lost, right? Especially if you are like a new kind of developer that have not seen those kind of things before. So you can create a sub-agent that can do things like an architecture review for you. It can create a sub-agent that can create some test use cases for you, because you may not know how to do all those things on your own, and you don't want to use the normal agents mode for it not to get confused with the new code. So there's different use cases for sub agents. The third case would be incident response. So when production breaks and pressure is high, this is not time for everybody to do the same work, right? So one sub agent can trace the failure paths and the likely causes, while another sub agent can prepare or check or confirm the fix. So that way the agents are both working hand in hand. Like after one agent work, the other agent work, and they have the same context as well. And finally, another reason why people use sub agents would be before shipping your code, right? You want confidence. So one sub agent can check what is missing, what are the weak coverages. Another agent can check, okay, what is our documentation like? What are the release notes? So these are the reasons why people used to use sub agents instead of using one agent to do everything. It's just like a human person, like just like our jobs as well. If one person is both the admin and support engineer and principal software engineer, you're going to break eventually. You're going to start hallucinating. You have too much context. You don't even know what to write to call. But when you have different roles in the organization, it starts to make sense. I know that, okay, my role is just to do testing and testing alone. So that way, I'm going to make sure that I'm doing everything right by doing testing, right? If my role is, again, to provide documentation, I know, okay, I'm the documentation agent. I'm not going to get confused. That is my role when it comes to development, right? So that is an example of using sub-agents. I'm going to show us how it looks like in production with one I've already created before. I don't think I would start creating all this from scratch. Do we have any questions so far? Okay. So let me show us the one I created before this class. All right. So this is an example of sub-agents. So I have the debug sub-agent, I have the doc sub-agent, I have the research sub-agent. We can see the name of the agent, we can see the description of the agent, and we can see what it does. So this is a read-only architecture investigator, right? It's always going to return these files to update, why each file was impacted, and API contract deltas, etc. Let's look at the documentation sub-agent as well. So you're a documentation finisher. Draft clear beginning friendly documentation updates from implemented behavior. So always return what I've changed in the documentation. Always, you have some constraint as well. And you also want to end the documentation like, okay, this is high, this is medium, or this is low. And how do we create this sub-agent, you may ask me. Let me bring back our week 3 so we can create one that is from scratch and we can see what it looks like. So again, the plan mode has finished running from our previous demo, but I'm not going to start implementation yet. But you can see the checklist that's created, like, okay, this is step 1. It already knows what to do. Step 2, it knows what to fix. Step 4, it already knows to add new test functions, right? Because we only had 4 test functions before. So it has added more things, but has not made those changes yet. So now when it comes to sub-agents, you will come here and you click on configure custom agents. So this is where you create your own sub-agent that is going to be doing some specific work for you. And you can always generate an agent using AI, or you can create your own manually. So all the agents you have to create has to be under .github/agent. But if we say we don't have .github here, so I'm just going to do this on its own, and let's create the agents. What's the agent's name again? I think the agent's name is, give me a second. Research sub-agents, this number 1. So I'm going to come again to configure custom agents, create new custom agents, use this and name it this. And I click on enter. So once I click on enter, we can see that the sub-agent has been created in this new folder that was created here. And this is now where you make the changes to what you, first of all, describe what this agent does. If you have an argument to describe what inputs the custom agent expects, right? And also to give it a definition of like what the agents do. So this is how you are able to create your own sub-agents in this whole GitHub Copilot agent. So these agents can be reusable, does not have to be only used once. So for example, next time they want to make changes to the application, you already know you already have your testing sub-agents, you already know you have your debug sub-agents. So you don't have to come here, change to agent mode, and every time be asking the same question all over and all over again, because you already have your sub agents that they already know their job to make those changes right for you. Documentation, for example, research agent, for example, to research the particular code base. So that's an example of when to use sub agents. All right. So let me go back to our slides and let's keep on going. So now we've spoken about sub-agents. Now, how do we do the testing? Sarah spoke about testing, but I'm not a developer, so how do I know what I'm testing for? Again, you can use Copilot to assist you in the testing, right? For example, you've already made those changes, or you've already asked Copilot to make a lot of changes on your application. Maybe you see the application is not working in some particular type of way, some button is not working, so you make those changes, but you need to test those things, right? So that's how you test with Copilot. So I think in week 2, I already showed us some kind of commands, and /test is one of them, right? So I'm not going to reteach those command bases today. So today we're going to focus on the test intents. What are the risks each test type is meant to detect? So testing is not about writing as many tests as possible. And you need to be aware of this if you want to be like a developer, right? You need to be aware of what to do to look for when you're writing tests, what to look out for. So testing is about covering the risks that actually matter. On the left side of this slide, you can see 5 coverage dimensions. Each one protects against a different kind of failure. And on the right side, you can see the example prompt you can give to Copilot to generate tests in each category. So the first dimension is happy path. This is like the most basic check. Does this feature work when the user does everything correctly? Or I click on I click on sign in. Is my sign in working, right? So those are the kind of things you want to check out for as a basic test. Then the second dimension is called edge cases. So this is what is valid but unusual. For example, if somebody puts a date in name, that's an edge case, right? So normally our user input of when they are supposed to write their name can accept their names. But what if the person puts something that's not a name, right? Something that is different. So you want to test those edge cases, right? When it comes to testing. So Copilot is very good here because it can suggest cases that a human may overlook. Then the third dimension when you are doing your testing is error states and input validation. This is where you send bad data on purpose. So what happens if somebody sends a missing title, right? Or an invalid date format? For example, if you're using DDMMYYY and the person puts MMDDYYY, right? You know there will be an issue when the person puts 3001 instead of 0130 in your own case. I'm just using that as an example. So what should happen? Your test should be able to validate like, oh, this returns an error that the user is going to see. So that are the kind of test cases you want to see. Then the fourth dimension is contract boundaries. So this is where you shape your API response. Like if a front end expects a field called due date and we accidentally rename it or remove it, your test should catch that immediately, right? Then the fifth dimension is regression check. Every time you add a new feature, you risk breaking something that's already working, which is true. Anytime you try to add something new, maybe something that was working before may even fail. So regression tests rerun all the older scenarios after the new code is added. So I want us to take a snippet of this. I'm going to share these slides as well. So when you are building an application, these are the things you should test for because you don't know how the users are going to use these things, right? So you want to make sure that all these things are well covered for. So now look at the right column. So instead of asking Copilot for generic tests, we ask with intent. We say things like generate test for invalid payload, right? So for an example, if you want them to pay into your application. So these are the kind of things you want to add. For example, if your user is supposed to add a number and they add -100, what should happen, right? Because -100 is still a number. So these are the kind of things you want to cover when you are doing some testing. And that brings me to what we call TDD with plan agent. So TDD is test-driven development. And the code idea is simple. Before you write the code, you want to write the test. And this is where it matters when you're working with an AI agent. So in your first step, again, as we mentioned before, you start in plan mode. Before anybody writes code or test, you describe what done looks like. For example, when I create a task without a title, my API should return error 400 or error, whatever error it is. Then step 2, you ask the agent to generate only the test files, no code yet, just the test files alone. Then step 3, you run those tests, and every single test is supposed to fail. So you should observe the failure, because this will be done in your hands-on lab. So understand the failure why this thing is failing when you run that test. Then in step 4, you now switch to agent mode again and ask it to write the minimum code needed to make the failing test pass. So first step is to define acceptance test. Second step is to generate the test only. 3 is to observe the failure. Don't write the code that's going to fix the test yet. Observe the failure, why it is failing. Step 4 is to implement a minimum code that will make that test to pass, right? Then step 5 is to do a cleanup. So once the tests are green, you can ask the agent now to improve that code structure, to rename the variables that is needed, or to simplify the logic, and before you now move on to continue to code. So why does this matter? It solves the biggest risk with AI agents. You don't want to lose control, because these AI agents will keep building stuff. It's very powerful. It's going to build an application for you in less than few hours. So, but you want to put all these things in place to make sure that, okay, even though the AI is the one building, I'm the one creating all these tests that the AI is using to build this application. I'm the one checking out, okay, this validation is actually working. I'm the one checking out, okay, my application, when the user wants to pay, I'm not storing the user's Visa card information, So things like that, you want to make sure that you're checking all these things and you make sure you're adhering to the AI responsible principle. So you want to make sure that you're putting all these things in place. It's what we call the test-driven development. You make sure that it fails first, you observe the failure, then you ask the agent again to give you the code to make it pass that particular test that has been created. I hope I'm not confusing us too much by so much English, right? But if we have any question again, please feel free to ask the question. So it's not about creating application and just walking away. It's about making sure you're using AI responsibly. It's about making sure that you're testing these edge cases. It's about making sure that you're observing failures. Why is my app failing? And understanding the code, and not just, oh, Copilot creates me an Uber application that looks like Uber, right? So you want to make sure that all these things are in place, right? Now, after testing, you want to do what we call debugging. So debugging is like identifying bugs that are in your code and being able to fix them. So when something breaks, most beginners, like myself, I'm not a software developer, panic, and we start changing the code randomly. We start asking the agent to change the code randomly. But this slide gives us a 5-step chain that we can follow every single time. So it works like a checklist, so you can stay calm and fix things methodically. So 1 is capture. So before you try to fix anything, collect the evidence. What is the error message I'm receiving? Copy the exact error message. Back in the days, we'll carry that error message. We go to Reddit, we go to Stack Overflow to check, okay, what is this error about? So the first thing you want to do is save that error, right? Write it down and see, okay, what is the thing that is causing this failure? So if you skip this step and just asking the agent to fix it for you, you will waste your time guessing later, and you may not even know what went down along the line. So the second step is to interpret. Remember, we have the ask mode, we have the plan mode, and we have the agent mode. So now it's time for you to use your ask mode. Use the ask mode and ask, like, okay, I'm getting this error. Can you explain the root causes, right? So now the ask mode will start explaining to you. Copilot will read the error and tell you in plain language what went wrong, why it went wrong. You're not fixing anything yet. You're just trying to understand the problem. Step 3 is to localize. What this means is that you're narrowing down exactly in this code where that bug is. So you don't need to start the entire project. In VS Code, you can point to Copilot to a specific file, or even as I showed us in week 1, you can always point Copilot to a specific file, or even highlight a specific section of code, right? Let me just show you what I mean by that. So in this example now, if I want to make a changes to a particular file, I can just do +sign here, and it's going to make changes to this particular file. I can ask it about this particular file and this file alone, right? Same thing for any other file that I have here. I can always, once I click on it, you can see that it appears here. So I can click on plus, I can do ask mode and like, okay, tell me about this file. So when you are doing your debugging as well, this is something, so you don't make changes to the whole application, right? So it's taking time. So you don't make changes to the whole application. So you can use hashtag file, hashtag selection, or you can even do the same way I just showed us right now to the defect area. So that's what I mean by localize. So it focuses the conversation so our Copilot looks only at the relevant area, not guessing across the whole project and wasting our time. Then the step 4 now, after we've already captured what the issue is, we've used ask mode to explain the root causes. And during the root causes, we've established that, okay, the problem is from our app.py, right? We've isolated the defected area. Now we now switch to agent mode and ask Copilot to fix that specific problem that we have identified. So you're asking for the smallest change that solves that bug. A kind of group prompt, good prompt in this instance would be, fix the validation error. The bug is on line 42, where the date format is not checked. Simple. So you don't want the agent, excuse me, to go around and around and around fixing what should not be fixed. So you localize the file, as I've shown you in the Github Copilot. Then you ask the agent to fix that particular validation error on line 22. Again, everything in our code, there are lines there, so we can see that there is line 28, line 19, line 21. So when we've used ask mode, we already know where the issue is, right? So we just ask Copilot to fix that particular line after selecting the particular app.py, like, okay, fix the particular issue in line 21. So that way, when we are debugging, we are not making changes, we're not getting confused. Because again, the agent can always hallucinate if you don't give it a good prompt and make changes to the whole application. Meanwhile, just one button you want to change, and now you're back to square one. Then the final step is to verify. So after the fix is applied and you run your test, you have to run your test all over again. And if all your tests passes, that means the fix works. But you also have to add one more test. I spoke about regression test earlier on, that everything that was working before is still working. So the new thing you did is working, and the way the app was working before is still working, only with additional step that has been fixed, right? So that way, if someone even changes the code later, again, you are working in teams, right? It's not only that will be working. If someone changes the code later and reintroduces another problem, those tests is going to catch it. So now the reason why I'm doing this thing step by step and why it matters is because you need discipline under pressure. Because sometimes we may get very excited or we may get very nervous if we have a bug in our code and we start changing everything all over again. So you don't want to do that. So the right way, the right methodology is to do a capture, to ask, then change to interpret mode, use ask mode to explain the root causes, you localize it, use the file, you do your patching, and you verify that it's running with tests. Okay. Then the next step I want to move to after we've done our debugging, we've done our testing, is documentation. You want to make sure that, yes, my code works, but how can other people understand and run it quickly? That is where documentation comes into place, right? So documentation with, code without documentation is a problem for everyone tomorrow. Yes, today you understand how your code works. Oh my God, I know my code works very well, but it's a problem for everyone tomorrow. Even me, I have some articles I wrote online, and sometimes I'm surprised, like, oh, I wrote that script, I wrote that PowerShell command, I've forgotten about it. But if I don't document it in a way that I'm going to understand, right, it's going to be a problem for not just me, but for everyone tomorrow. So this slide is about making documentation a part of your delivery, right, not an afterthought. For example, if I'm going to give you an assignment, like at the end of week 6, a capstone project, and I'm looking at your documentation, I should be able to understand what your code is all about without me going through all your 1,400 and something line of code. From your documentation, I should be able to understand the workflow, the architecture, what this does, right? So that's what documentation is all about. It also helps when you're working in team. I think Chisom was mentioning something last week about an open source documentation, right? Sorry, an open source project. For example, if 4 of you or 5 of you from this session wants to create an application together, if there is no documentation, you're going to get confused on what has been changed. You're going to get confused on what something does. And nobody wants to waste time, like, reading something all over and all over again, or asking Copilot how it works all over and all over again, and wasting, what's it called, tokens. Remember, we are paying for these tokens. They are not free. So on the left, you will see 5 types of documentation that Copilot can generate for you after a meaningful change. The first one is document strings. So what's a document string? It's a short description written directly inside a function that explains what it does. So those your hashtag, like, when you are, writing your code, if you're using Python, for example, you use hash to write, explain what a particular function does, etc. Right? Let me see if I have anyone in. Gosh, I have a very terrible documentation in my own code. I'm not the best example person to give. Okay. Right. So this is an example. This is something very simple. This is an example of we are documenting something, right? So I'm ensuring the project, this is what this code does. So this explains what this code does. Ensure project root is importable, right? That's an example of documentation. The next example is a README file. So a README is the first file people read when they open your project. So if you upload your project to GitHub, the first thing people are going to see is your README file. Let me look for an example to show us. Let me see. Give me a second. Let me see. Repository. Let me go home. No. Give me a second. Let me just quickly sign in. Hope I'm able to sign in fast. Okay. All right. So let me just show an example of a README file in GitHub when you push your code to GitHub. Okay. You can see that I also have terrible. I'm not practicing what I preach apparently. All right, I think I have one that's in the public there. All right, so let's look at an example of like an application that I created using GitHub Copilot. So this is what a README file looks like. So when somebody comes to my GitHub profile, the first thing they are going to see is this README file. So this was generated by AI, right? So they can see the features of what all this code is all about. They can know, okay, the tech stack that I used, okay, she used AI Foundry, she used blob storage, she used this. You can see prerequisite as well if you want to clone, if you want to create your own version of what I created. So this is an interview coach. It's a video interview, and AI is interviewing you back to back. You're talking to the AI is answering you back, giving you like feedback, real-time feedback as you are doing your interview, right? So this is the project structure, what I used to build the application, how it works. You upload your CV, you add the job description, either the URL of the particular job you saw, and the timing, 30 minutes max. What happens if you don't reach 30 minutes, right? And what we used to deploy it. I use Azure App Services. And when it comes to security, what did I do in security? Again, all this is generated by AI. I didn't write any of this from scratch. I'm not going to take credit. So all this is generated by AI. But this is an example of a full-blown application that was built using GitHub Copilot, right? So this comes back to my documentation workflow. You want to make sure that you add your README, that when somebody wants to clone your project, if you are doing a very good work, someone wants to clone your project, they are able to see how to install the application, how to run the application, and how to use the application. The third kind of documentation is the API documentation. So if somebody wants to use your documentation as your API endpoint, for example, which company do I use? We are creating a reservations airline kind of application, and you go to all these airlines, right? They usually have like their own API documentation that you can use to create your own application, that you can point straight to their own application and use it as well. So if somebody wants to point to your own application, you need to create a very good API endpoint documentation for them as well. Then the fourth kind of documentation you want to create is a change log. So version 1, what changed between version 1 and version 2? So you want to create that kind of that kind of documentation as well. So why did version 1, what happened between version 1 and version 2? So people in your organization can be able to see, okay, this is what happened in version 1 and this is what happened in version 2. So also Copilot as well can also look at the code differences and summarize them for you. And the final kind of artifact or documentation that you want to create is a PR summary draft. So when you submit your code for review, a clear summary, so PR is pull request. If you want to make changes, for example, to your company's organization code base, you need to put a PR. You need to do a pull request and put a summary. So don't just put something vague, right? AI can always help you to generate. I think I will show us in the next weeks to come as well. So on the right, you will see a quality checklist. This is how you evaluate whether the generated documentation is actually useful, right? So first thing first, it must match the current behavior. If the documentation says the API accepts 3 feeds and the code accepts 4, that means the documentation is wrong and it is stale. So you want to make sure that anytime you make changes in your code, you're also making changes in your application. Second thing is that you should also include the edge case notes. The same way you also do it in your test as well, you also include it in your documentation. Another example would be to show examples and commands. Can be in your README file as well. You want to show the kind of example that you're looking out for or that people can use to create their own application based on what you have, right? For an example would be like this that we have here. In this documentation, there's an example of the commands to use, right? So run this command if you want to install this, right? An example of your environment file, an example of running it in development mode, built for production. This is what you use to run it in production. So these are the kind of things you want to put in your documentation, and this is how you validate that it has good quality, right? Another thing, again, you want to use consistent terminologies. You don't want to start changing your terminologies, right? If you are calling it task, make sure you're calling it task all across. If you are calling it item, make sure you're calling it item all across. And finally, no stale references. If you removed a feature last week, remove it from documentation as well. If you've added something, you add it to your documentation as well. So from the difference between what we've done from week 1 and week 2 is now is that we're not just creating a mathematics application as we did in week 1 and week 2 just to add something. We are trying to create something more deep, something more technical, right? So finally, for our final demo, I've already created it as well, would be to show us how this works end to end. So basically what I did here is I updated my README file. I updated into a UI as well, because we're talking about API, we're talking about backend. So what it looks like in real time now, this is what we've created. So I just told Copilot, again, I have the documentation here as well, to add, let me show us. What I told Copilot in the agent mode now is to keep the API behavior unchanged, our backend, keep it unchanged, but it should build a front-end UI, right? That is where our user interface, where our users can use for the task application. So we've already built the back end. We've done our testing. We've done plan mode to do our testing as well. We have our test files. We've built our README. So the next thing we did now is to do a front end UI after doing the backend, and we're sure that the backend is working. So this is what it looks like, and this is what you're going to be, what I expect to see in your hands-on labs as well after this session. I'm looking at time. We are far over time. So now an end-to-end workflow, right? Before wrap up. So at this point, we have one continuous project journey. We had an empty folder. We did an API. We enhanced the API. We did some testing. We did some debugging. We did our documentation. And finally, a polished UI, right? So this is what an AI native delivery pipeline look like. So this slide pulls everything together. So think of it as a full recipe for delivering a feature from start to finish using AI assistance. So each box at the top represents one stage. So step 1 is issue. Before anybody writes the code, you capture what needs to be done. This could be either a bug report if the app is already working before there's a bug. It can be a new feature request, right? Or it can even be creating a new application from scratch, right? Then the next thing is plan. So you switch to plan mode. You ask for a structured plan before any code is written. So the plan lists which files will be changed, what order to make the changes, what risk already exists. So you review this plan as a team with your teammates. You challenge anything that looks risky or incomplete, right? Before you now move to the agent mode. So the agent mode is what makes you execute the approved plan, right? It writes the code for you only within the boundaries you've agreed on. Remember, I told you about using the file feature, right? So you're not making changes to all your application. You're only making changes to that particular file Then the fourth step is testing. So after the code is written, you run your test to verify that it works, which includes, again, as I mentioned earlier on, your API testing, your edge case testing, your regression check, right? If your test fails, what do? You go back to step 3 again and fix. So testing is a proof that your code does what the plan said it should. Then step 5 is debugging. If something breaks during testing or review, you follow the debug workflow that I mentioned earlier on as well. You capture the error, you interpret it, you localize it, you patch it, and you verify again with new tests. So this is not a one-size-fits-all. You need to keep on going back and going back. Then step 6 is document and pull the request. So pull request is just to merge it to production, right? So make sure you're documenting all the changes that was made, your versioning, etc. Then pull request, a human like your manager reviews and approves the request and now merge it. So this is what an AI native delivery pipeline. So this is what it looks like when you're using AI, using GitHub Copilot to build an application, right? So governance stays with the team. Know when to use an agent, know when to be a human person to go and review these things yourself, right? It brings us back to our week 1 about using AI responsibly. So now for our quiz, I want us to, the chat session is now working. So I want us to, this time around, I'm not giving us options. I just want us to either come off mute or guess what the answer should be, right? So the first question is, what is the best mode to design multi-file work before coding? So let's put our answer in the chat. What is the best mode to design multi-file work before coding? There are only 3 modes. There's ask mode, there is plan mode, and there is agent mode. So what is the best mode to design before coding? Plan mode, yes. Any other answer? Yeah, plan mode. Yes. So the best mode to design multi-file work before coding is plan mode, right? So the second question is, sub-agents are best for what kind of task? So now be creative because there are no options. So when do you think you want to use sub-agent? Remember I created different sub-agents to use to do some task. So in your own word, when do you think you should use a sub-agent? When do you think you should use sub-agents in your own word? To break down parent tasks, yes. That's a good answer. Thank you, Lola. So when do we think sub-agents are best? Multitasking, yes. That's a good answer to Oluwafemi. All right, because of time, I'm going to move to the next question. So what is the safe order for complex work? Is it ask, plan, agent? Is it agent, plan, ask? Is it plan, agent, ask? So what is the safe order when you are doing a complex work? What is the safe order for when you are doing a complex work? For example, you are employed as the new developer in your environment. You already have the project there, and they ask you to make some changes. So do you just go straight into agent first? Do you go straight to planning first, or do you ask to understand what is this all about before going to planning, before going to agent? So what is your own flow? So what is the safe order for complex work? Is it ask, plan, agent, plan, ask, plan, agent, ask, plan, ask, agents? Okay, I'm seeing some answers. Elvis, when installing a new feature, yes, that's correct. So ask, plan, agent, yes, that's the right way to go about it. So you ask first to understand what is going on in that particular project. Then you plan the changes you are supposed to put, right? Before you now ask the agents to make those changes. Good. Then, final question. What defines done in an AI native delivery? So is it you write code, test, documentation, and review, or do you review first before you do your documentation, before you write the code? So what in your own understanding, what defines like, okay, I'm done. I've done the code, I've done the testing, I've done the documentation, I've done the review, or I do documentation first and I do the test after before I now build my app, before I now do review. So in your own word, what do you think the AI native delivery is based on what I have discussed to us earlier on. Okay. Okay. All our answers are correct, by the way. Okay. Okay. All right. So let me just go back to that slide so that we see it again. So it is first understand the issue, then you plan, then you code, then you test, then you debug, then you write your documentation before final review. So review is the final thing you do with your manager, etc. Right. So these are the key takeaways from our session today. 1, agent mode is outcome driven, not snippet completion. Plan mode helps you to reduce the risk before the code changes starts. Sub agents help you unlock better decomposition. You want to make sure you are testing and debugging loops. They're also mandatory for reliability, and documentation should be generated and validated in the same workflow. Okay. And these are the references again. I'll share these slides with us. And for the hands-on lab, this is our final thing before we call it a day. So we have 3 labs in this particular week. Please submit your lab. So the first thing I want us to do is this task API I've built. I want you to also build the same thing as well. So you're going to build a task, an application that you can create tasks as well, right? So these are the success criteria for the first lab. Can I create a task? Can I list a task? Your application should be able to do that. If I add priority, does it disappear when I list the task? So that are the things you should check out first for your first lab. So you want to switch to plan mode, ask for a plan to cover all these things. Then the second lab is that's the back end. So this is the back end. So you need to have tests that make sure that those your back end is working. So you need to do tests. Again, you've not seen the application, the UI yet, but you should be able to do some testing yourself first to test that it's actually working. Then the second part of your lab is to add a bug yourself. So you need to create a bug, right? So you can understand how bugs get introduced, right? And find them in real projects. So create a bug yourself and fix the bug yourself. So that's your lab 2, right? Create a bug, fix the bug yourself. So after you create the bug, you change back to ask mode for diagnosis before you now change back to agent mode to fix that particular bug you created, and also test that your app is still working as it should. Then finally would be to create the UI of that. I'll change this. So create the UI of this task you've created, that task file that I showed you. So create the UI, create a documentation, and if you are feeling bold, upload it to your GitHub, because everybody has a GitHub account. Upload it to your GitHub and share your GitHub repository with me. Else, you can just do it in the locally and just share me a screenshot. So how do you know you are done? You can share me a screenshot of this, right? I will know, okay, you are done with creating this. And also share this side of your code as well, so I can see all the files that was created. So I know you are done. But if you're feeling bored, upload it to your GitHub and share the GitHub repository with me, and I will take a look at it when I have the chance to this week. So please fill out your form, your attendance form, so we can know those that attended the class for today. Thank you so much for week 3. I look forward to seeing us in our next class, and we'll take it up from there. Let me stop recording, and if we have any question,